This video will walk you through how to solve absolute value equations. Absolute value equations are just like they sound. They're equations with absolute value signs. When we're solving an absolute value equation, the first thing we want to do is isolate the absolute value. So we want to get this absolute value and whatever's inside it by itself. So to do that, I'm going to subtract 9 on both sides. That gives me x, the absolute value of x plus 5 equals 3. Something to note when we're working with absolute values is an absolute value of a number is the distance from 0 on a number line. Okay, so if we put this on a number line, if we want to be 3 away from 0, we could either be at 3 or at negative 3. Since distance is non-negative, the absolute value of a number is always non-negative. So whatever is behind this question mark, it could equal 3 or it could equal negative 3. And that's our step 2, is to set up two equations. This x plus 5 that could equal 3 or it could equal negative 3, because if the x plus 5 equals negative 3, that absolute value is going to turn it into a positive 3 and result in making this equation true. So I'm just going to go ahead and solve these now real quickly. I'll subtract 5 to get x equals negative 2. Subtract 5 again. I get x equals negative 8. Most of the time with absolute values, we're going to have two answers. Last thing we want to do is check our solutions. We had solutions of negative 2 and negative 8. So we're just going to plug those back in, make sure that they work. So if I plug in negative 2, to see if that equals 12, well, the absolute value of negative 2 plus 5, that's going to be the absolute value of 3 plus 9 equals 12. And we can see that that's going to end up being 12 equals 12. So that solution works. We would try the same thing with negative 8. So absolute value of negative 8 plus 5 plus 9, and we want to see if that equals 12. That will be the absolute value of negative 3 plus 9 equals 12. Now, the absolute value of negative 3 simplifies to just 3 plus 9 equals 12. And again, we see that that solution of negative 8 checks out. A little more complicated, but we're still going to go through the basic 2 or 3 steps to solving this, which the first one, remember, is to isolate the absolute value. If I want to get the absolute value by itself, a little side problem, if you're confused, you can always think about it as this: 3a minus 2 equals 10. Replace that absolute value with an a, and the steps you would solve to get that a by itself are the same steps you'd use to get the absolute value by itself. A lot of people want to distribute that 3. Do not do that. No, don't do that. So I'm going to isolate this absolute value. I'm going to add 2. You get 3 times the absolute value of 2x minus 5 equals 12. Then I'm going to divide by 3 or multiply by 1/3, whichever floats your boat. And now I have the absolute value of 2x minus 5 equals 4. Now that I have that absolute value by itself, the second step tells me to set up two equations. Now, I don't change anything about this. 2x minus 5 stays the same. But 2x minus 5 could equal 4, or it could equal negative 4. And then we go about solving each of these equations. So I would add 5 to both sides. If I do that, I have 2x equals 9 over here on the left, and I have 2x equals 1 over here on the right. So I get x equals 9 halves and x equals 1 half. Our final step would be to plug these back in and check our solution. I'll do this quickly. If I plug in 9 halves for that x, or I could plug it back into the original equation as well. But 2 times 9/2 is 9, 9 minus 5 is 4, and we're all good there. Same thing with 1/2. If I plug in 1/2, 1/2 times 2 is 1, and 1 minus 5 is -4, and the absolute value of -4 is 4. Here we see there's a variable on both sides of the equation. So nothing's going to change. We're still going to go through our normal steps to solving this. First being is to isolate the absolute value, which in this case, it's already isolated. So I can go ahead and set up my two equations. I can set up x plus 10 equals and x plus 10 equals. Now remember, we're only negating what's outside of the absolute value. So in one equation, we don't change anything. 4x minus 8. That can equal 4x minus 8. But it could also equal negative 4x minus 8. Now if this was just a number, you would just say, if it was just 4, for example, we would do 4 and -4. But because we have some other variables and constants there, we have to negate the entire side. And then we go about solving this. So I'm going to get all the x's to one side. So I'm going to subtract x over here, and I'm going to add 8 over here. I end up getting 18 equals 3x. X would equal 6. Over on the right side, I want to distribute my negative. Negative 4x, and when I distribute the negative, that -8 turns to a positive 8. So again, I want to get all the x's to one side, so I'll add 4x to both sides, and I'll subtract 10 to both sides. I end up getting 5x equals -2, so x equals -2 fifths. Now if I were to plug these solutions back in, if I plug 6 back in, you have the absolute value of 6 plus 10 equals 4 times 6 minus 8. Which after some simplifying, you get 16 equals 16, so we're all good here. If I plug -2 fifths back in, running out of room. After some simplifying, what we end up getting is 48 fifths equals -48 fifths, which of course is not true. So that is an extraneous solution is what it's called. So our only answer in this case is 6. One last special case. It's sort of unnoticeable. It does look like a normal absolute value equation at first. So we're going to go about isolating this absolute value. We'll subtract 8, subtract 8. You end up getting the absolute value of 3x minus 2 equals -7. Now if we pause and think about what type of number this side is going to be, the absolute value is always going to be a positive number. On the right side of our equation, it equals a negative number. Now a positive can never equal a negative, so if you ever have an absolute value equaling a negative, that is no solution.